Bismillahirrahmanirrahim. Assalamu alaikum dear students. Welcome back in lecture 01 part 12. Student, as you see in the part lecture 01 part 12, we define the difference between analysis and design. That what is the difference between these two. So in today's lecture I will summarize the steps which will be followed in the analysis or review problem. Whenever we are facing any type of problem which is a review problem or which is an analysis problem, what steps we have to be followed and how to approach that problem. So the first step is step number 01. We have to use an assumption. Remember, we have to use an assumption that stress in steel equals to the yielding stress. This one will be the first assumption. We have to prove this assumption by in later stages, that whether this assumption is right or wrong. We have to prove this. Then the next step is we have to find out the depth of concrete block. You know the depth of concrete block, that is, let's say this is my equivalent rectangular stress block, which is C, that is the compression force, and this extreme fiber compression is 0.85 FC prime, and the depth of this block is denoted by A. We all know this, I have explained this in previous part, and this is A divided by 2, right? So we know this, and we derive this equation for A, that is area of steel times Fs divided by 0.85 FC prime into B. Here we will insert for Fs equals to Fy, so that by we will use Fy divided by 0.85 FC prime into B. This one will be the final equation of A. Then we know the depth of concrete block, or the depth of neutral axis. We know this is my neutral axis, and the depth of the neutral axis is denoted by C. So C is calculated, it is calculated by A divided by beta 1, because we know that A equals to some fractional distance of C beta 1. Remember, the beta 1 value should be adjusted if the FC prime value is greater than, is equal to or less than 4000 psi. Then we know the beta 1 value will be 0.85. I have already discussed this. But if FC prime is greater than 4000 psi, so beta 1 will be adjusted by using the equation 0.85 minus 0.05 into FC prime minus 4000 divided by 1000. Please check this equation. By using this equation, we will adjust the beta 1 value for this condition, right? If let's say FC prime 5000, we will use this equation and we will derive the exact value of beta 1. After finding the value of A and C, then we will check that assumption, whether that assumption is okay or right or wrong. So this is step number 3. This is step number 3. So in step number 3, we will find out the strain in steel, epsilon S. That is, from proportionality we have derived this equation D minus C divided by C into epsilon U. We know epsilon u is, we will use the criteria that is 0.003, and d will be calculated. We know c is, we will already calculated as in above steps. Now we have to find out epsilon y. Epsilon y is calculated by Fy divided by modulus of elasticity of steel. We know modulus of elasticity of steel, that is 29,000 ksi, right? So for concrete it can be this is modulus of elasticity of steel, right? But for concrete, modulus of elasticity is 33 times unit weight of concrete की power 1.5 into fc prime under root. Now once we got the value of epsilon y, we have to check that assumption. How to check it? If epsilon s is more than epsilon y, this is important, so this means our assumption is right. Means the assumption fs equals to fy. This means what? This assumption means what? This is important. What does it mean? This means our steel is yielding. Steel is yielding, and we have an under reinforced section. This is important. We have an under reinforced section, right? And after finding that, we are able now to find out the Mn value. It can be found out by using A is Fy into D minus A over 2R. It can also be derived, or it can also be determined by C times lever arm. C means C times lever arm D minus A over 2, and we know the value of C, that is 0.85 fc prime B into A into D minus A over 2. We have already find out the value of A. We know the value of B, fc prime, so we can find out the value of Mn. Both equation will give you the same results. This is important. Now after that we will adjust the phi factor. This is, let me write down the steps. This is step 3, and this is step number 4, and this one will be the step number 05. We have to adjust the phi factor. How to adjust the phi factor? As we calculated the value of epsilon s, right? If the steel is providing in one layer, right? This is important. If steel is provided in one layer, in this case the effective depth D is equal to dt. I have already explained this in my previous parts. So D equals to dt, and in this case epsilon s will be equals to epsilon t. Now epsilon t, if epsilon t is greater than or equal to 0.005, so we can clearly move towards that p equals to 0.9, right? We know the graph. I have recorded already a lecture on a part on it, right? We know the graph that, let's say from this graph we know that this is my graph, I think so, part 9, how to adjust a p factor. So this is my graph, right? This value, this axis denote the p value, and this axis denote the epsilon t value, right? So here is my value. This value is 0.65, and this value is 0.9, and this value is 0.002, and this value is 0.005. This is my tension zone. This is my transition zone, and this is compression zone. This one is compression zone, right? This one is compression zone. Now, if this condition is satisfied, means we are in transition zone. This means we are in transition zone, and we can use P equals to 0.9, and we can easily find out the Min, that is the design capacity of the section, is 0.9 will be multiplied with Mn value as we calculated above. If, let's say, the value of epsilon t is less than 0.002 here, so this means we are in compression zone, and in that case the phi value will be 0.65, and in that case the Mn value will be the design capacity, Md, will be found out by multiplying 0.65 with the Mn value. This is important. If let's say the epsilon t value is greater than 0.002 but less than 0.005, this means what? We are in transition zone, and in this case we will find out the p value. We have to adjust the p value in this time. That can be adjusted 0.4 at plus 83.3 epsilon t r. It can be adjusted by using the SA equation, that is 0.65 plus epsilon t minus 0.002 into 250 divided by 3 for the case of tied case, when we have tie reinforcement, our ties will be used, right? In that case this equation will be used, these two equations will be used. For spiral this equation is different. I will share that equation as well in coming examples, but this should be remembered. Now the p value can also be adjusted by, this is step 5, right? The p value can also be adjusted by an alternative way. This is an alternative way. Alternative way is this, that we will find out the value, the ratio of C by dt. Now if C by dt is less than or equal to, I have already discussed this in the previous part, is less than 3 by 8 r C by dt is less than or equal to 0.375. This means that P is equal to 0.9, right? We can directly say that P value will be 0.9, and the section is a tension section, right? If C by dt is greater than or equal to 0.6, right? So then we can say that P value is 0.65. But if C by dt is greater than, is greater than 0.375 and less than 0.6, right? This 0.6 can also be written as R 3 by 5. Remember, It can also be written as 3 by 5. So in another way, if c by dt is greater than 3 by 8 but less than 3 by 5, then the p value will be adjusted by using the given equation which I have already written, 0.48 plus 83.3 epsilon t. Right? This is the another way. Right? This equation can also be written in the form of c by t. I will share this equation in my examples. Right? Now, the next thing is, let's say this section is not a tension section. This is important. And now we have to understand this, that let's say F, that can be written as step 5, not step 5, let's say, let me show you the previous steps, right? This step number 3, that if, let's say, epsilon is not greater than epsilon y. This is important, and this assumption is wrong. So what does it mean? This is important to understand now. Write this one. This is step number 3. Let's say that epsilon s is less than epsilon y. So what does it mean? This means that stress or steel is not yielding, means the criteria is wrong. Steel not yielding. This means steel is not yielding, and we have to find out the exact amount of stress in the steel. Mean that the steel stress is not reaching to the specified yielding stress. What will be the exact amount of the stress which is present in the steel? Now it can be calculated by using the Hooke's law. Modulus stress of steel multiplied by epsilon s. Now it can be modified epsilon s times d minus c divided by c into epsilon u. Now this value which we got here, you will see that this value will be less than fy. This means what? What is practically this mean? This means that the section is over reinforced. Section is over reinforced. We have provided a heavily reinforcement to the section. Concrete is crushed before the yielding of steel, and at this time, to proceed and to cover the rest of the question, we have to repeat again the value of A and the value of C. Now this is important. I have already discussed this, that how we can proceed in my previous parts. We will calculate the value Ku, and we know the equation for Ku, that is m times rho plus m times rho divided by 2 square minus m times rho divided by 2. I have already discussed, I don't discuss this, but from the value of Ku, what is m, what is rho, I already discussed it, but from the value of Ku, we know Ku equals to C divided by D, and from this C equals to Ku times D. We will calculate C, and from C we will calculate A. The value of A, we know that this is beta 1 times C. After this, we will find out the value of Mn. We will find out the value of Mn. Either multiply the C with the lever arm D minus A over 2, right? Or we will find out M by multiplying area of steel times Fs. Remember, this time we don't use Fy. This is a very important step. You have to make sure that you will use the value of Fs. And how to calculate the Fs? We will find this Fs from this equation. Remember this equation. We will calculate C. So here we will calculate C and we will insert this C value in that equation and we will find out the value of Fs. This is very important. We will multiply this with lever arm and we will find out the Mn, nominal movement capacity. After this, as we know the section is over reinforced, so we know that P, this is stiff number 04 and this is stiff number 05, right? So the P value will be 0.65 because this is an over reinforced section. So the MD, that is the design capacity, will be 0.65 times that value of MA. This will the steps which we will follow. After this, we can also check the minimum amount of steel. That will be step number 06. We will also check the S minimum, right? Whether it is less than or equal to AS given, which is given to us as provided. So AS minimum, we all know that AS minimum will be calculated. I have already derived this equation. Fy less than or equal to 200 divided by Fy. So this is the check which we will use in the coming examples. So we will check AS minimum. After that, we can also check the cover requirements, because whenever we are using a beam section, remember there are so many checks which we can use, but at this time in the coming example we will just only check for flexure. We have torsion checks, we have shear checks, we have so many other checks, but this time we will only use the checks for flexure. We can also check this cover which we provided here. This is clear cover and the spacing in between the bars. The side cover, this one will be the spacing, this one will be the bottom cover and this one will be the side cover. And I will discuss these covers, that what is the ASCI code criteria for this side cover, for bottom cover, and what will be the criteria for us. We will discuss this in upcoming lecture, but these are the steps which I have already explained, and we will cover these checks in the design process when we will design a beam. So let me discuss this in the coming lecture, but you have to understand these steps, that how to review a problem or how to review any given section or analyze any given section, which I will follow. Thank you for watching. See you in next lecture.